for section 5.7. Polynomial equations. All right, so what's the difference between what we were doing before, where we just factored a bunch, and what we're doing now? Before, we had expressions. There were no equal signs. We just had expressions and we practiced factoring those expressions. Now we're going to have those types of expressions equal to 0, and our goal is to figure out what x values make that expression equal 0. Okay, those are called the zeros of the expression, or the solutions, or the x-intercepts, lots of different names. So in order to solve equations or solve polynomial equations, the very first thing that we need to know that's very, very important is something called the zero product property. Okay, so our goal, let me take it one step back. Our goal is to take things like, we want to solve a simple one, something like x squared plus bx plus c equals 0. That's a quadratic equation. So we want to know when this is equal to 0. Okay, and solving this means we want to know what values of x make it true. And like I said, one thing that's going to help us be able to solve things like this is the zero product property, which tells us that if we multiply two things together and the product is equal to 0, the only way you can get a product equal to 0 is if either of your factors are equal to 0. So if a times b equals 0, then that means that a has to be 0 or b has to be 0. This is going to be very important for us when we solve our polynomial equations. But we need to remember that this only works for 0, okay? Two factors equal to 0, then each factor must be equal to 0. I'll give a quick example of that. So let's say we had something like x plus 2 times x minus 1 equals 0. So our two factors are x plus 2 and x minus 1. This property tells us that x plus 2 must equal 0 or x minus 1 must equal 0. And then these are two simple equations that we can solve. X then equals -2 and x equals 1. These would be our solutions. So that's how we use the zero product property. Usually we do this step at the end of our problems, but it's important that we understand it so that when we get to this step, we know how to use it. Right, there's a couple of examples in the book that go through using the zero product property. Like I said, we're going to end up using that at the end of all of our polynomial equation problems. Here are the steps, that we'll use for solving polynomial equations. So solving polynomial equations of the form p of x equals 0. So some polynomial equal to 0. We're going to use factoring to do this. So first, these ones should be set up nicely where you have your polynomial on one side and 0 on the other side. Every once in a while, you'll have two polynomials equal to each other or stuff on both sides. If you have that case, move all of the terms to one side using either addition or subtraction. And then once you have it set up nicely, polynomial equals 0, you want to try to factor. So our first step is going to be to try to use those factoring techniques that we solved or used in the last few sections. So factor the left-hand side of the polynomial as much as possible. And then you'll end up with some factors. Those are things being multiplied equaling 0. Then we can use the zero product property. Okay, so factor the polynomial, set each factor equal to 0, and then solve the resulting equation. Okay, and remember, for any equation, you can always go back and check your answer by plugging in your answer to the original equation and seeing if it's true. All right, so we're going to use this. Start off with our polynomial equaling 0, factor the polynomial. That's what we've been doing. And then now we're going to take it a step further, use the zero product property. Set each of the factors equal to 0 and solve. All right, the book goes through a couple ways that we can do this. Of course, we talk about solving many different ways. We can solve graphically, we can solve numerically, we can solve algebraically, and we're going to learn all three. Solving graphically for a problem like this is essentially just finding the x-intercepts. Okay, so here we're given the, sorry, let me make this just a little bit smaller. All right, here we're given the polynomial equation x squared minus 2x equals 0. Solving this graphically means we want to know when the expression or when the function x squared minus 2x equals 0, the output is 0 on the x-axis. So essentially, we're just asked to find the x-intercepts. Okay, so we're trying to figure out graphically where this function crosses the x-axis. And we can see it pretty clearly here. Crosses at 0 and 2. Okay, and we can use our graphing calculator to find these zeros as well. I'll show you guys in another example how to do these steps on your own graphing calculator to find the 0 and to find the 2. Right now, it's visually easy for us to look at and see it, but sometimes you might not be able to as easily see. So we'll talk about how to do this on the graphing calculator in just a second. Okay, and then we're also going to talk about how to do this algebraically. So this is by looking at the graphs. You solve by finding the x-intercepts. If you wanted to look at the table, we would let the calculator choose the x values for us, and we just scroll down the table until we find an x value that has an output of 0. Remember, that's what our goal is. We want to know when the function is equal to 0. So we can see here from the table that that happens at x equals 0 and x equals 2. Okay, and then of course you can check your answer. Okay, now before we go on, I just want to talk really quickly about how we can solve this algebraically. Even though we see the answer is x equals 0 and x equals 2, we solved it graphically, we solved it numerically. Let's solve it algebraically. It's actually not that bad. So we started off with, where do I have room? We'll do it down here. Our equation was x squared minus 2x equals 0. So we want to look at what's on the left-hand side, the x squared minus 2x. And we want to factor that. X squared and 2x both have a factor of x in common, so we can factor out the x. This would be x times x minus 2 equals 0. Now we can use that property that we just learned. That property tells us that if we take x and set it equal to 0, and x minus 2 and set it equal to 0, we get our solutions. So we'll say then x equals 0, which is one solution, and x minus 2 equals 0, which gives us x equals 2. That matches up, of course, with what we saw in the table and what we saw in the graph. All right. Bits of terminology that we need to know. What we're doing has a few different names. One, we're finding the solution to our equation, x squared minus 2x equals 0. We say that the solutions are x equals 0 and x equals 2. Also, we're finding the zeros of the polynomial p of x. And the zeros are also called the x-intercepts. So in this case, the solution, the zeros, the x-intercepts, all the same thing. I like to jump to the practice problems. Part A is already factored for us completely, so we can go straight to using the zero product property. Part B, we have to factor a little bit more. We can factor out an x minus 4 from both of those. For part A, he said the solution is x equals 4 and x equals 3. Okay, so from here, you should recognize that we can factor out the x minus 4. So that's x minus 4 times 2x plus 5 equals 0. Then if we set each factor to 0, we get x equals 4. And this one we have two steps. 2x equals negative 5 and x equals negative 5 over 2. So yes, those are our solutions. Now let's talk about how we can solve these graphically. First, on your graphing calculators, I'll share my screen for them. You have to, under y equals, enter in the left side of the function. So we're going to enter in x minus 3 times x minus 4. And then we're going to use the intercept feature to find the x-intercepts. All right, so you should be able to see my screen. Under y equals, let's clear out the old stuff, put in our new functions, x minus 3 times x plus 4. I'm sorry, x minus 4. When we look at the graph, and I'm showing you this because sometimes you might just be given the graph and asked to find the solution. Sometimes you're given the equation. We should be able to solve all three ways, graphically, numerically, and algebraically. I'm going to zoom standard here. That's going to give us our regular 10 by 10 window. And then we see the graph of this function. We want to find these points where the graph crosses the x-axis. We can zoom in a little over there if we want to also. I'll zoom in so you can see it a little bit more clearly. All right. Boom, there we go. So let's say we couldn't see clearly that that was a 3 and that was a 4. Then what can we do? We want to go to the calculate button. So press second trace, and there's a button called zeros. Zeros allows you to find the zeros or x-intercepts of a function. So if we click on 0, and this is where you have to follow steps because we have to do a lot of clicking for it to tell us the answer. So we're telling the calculator now that we wanted to find the zeros, enter. Then it's gonna ask you to pick a left bound and a right bound. That means you can visually see the 0. You need to pick a number or x value to the left of it. So I'm scrolling left until I pass the 0, and I'm gonna hit enter. Anywhere to the left of it works. Then right bound, scroll to the right, pass the 0, and hit enter. And then guess, yes, you have to hit enter one more time. Boom, it tells us that the 0 is at 3, 0. Notice this only gives us one of the zeros. We have to do this again with the next one. So to repeat this process, second trace, press the number 2, we're finding the zeros. And again, now we want this 0. So we need to pick up a point to the left of this 0 and to the right of it. Start off with something to the left. This is to the left of this 0, okay? So the x value that we're looking for is here. The cursor needs to be anywhere to the left of it. Hit enter. Then scroll to the right, past the 0, and hit enter again, and enter one more time. Boom, we see our other 0 is at 4, 0. That's it. Oh, no, we have to solve with the table also. Solving with the table. If we go second, well, I'm gonna change my table set. It's on ask. I want it to be on auto though. Change my table set to auto. Remember, the difference is with auto, the calculator automatically puts the x values in. With ask, you type them in, but I want it to automatically put them in. Why? So I can scroll. So when I scroll up and down my table, I am looking for where my outputs are 0. Boom. You see that the outputs are 0 right here when x equals 3 and x equals 4. So we've seen graphically, numerically, and algebraically that those are the solutions. All right, I just wanted to at least do a couple of examples focusing on solving graphically and numerically. For most of the other examples that we're going to do today, I want to focus on solving algebraically because those take the most steps. So jumping back in to section 5.7, the next thing we need to talk about is solving a quadratic equation. Many of the equations that we solve end up being quadratic polynomials. So that means we have x squared as our highest x value. Then we can use all of these different techniques that we've been learning about factoring, differences of squares, and perfect square trinomials. We can use all of those to help us solve quadratic polynomial equations. Come on, move out of the way. All right, so solving quadratic equations. First of all, a quadratic equation is of the form ax squared plus bx plus c. So ax squared plus bx plus c is a quadratic polynomial because the highest power of x is 2. And if we set that equal to 0, we get a quadratic equation. Okay, that is a standard form of a quadratic equation. Okay, to solve these, like I said, on the right-hand side, you have a trinomial. We can use any of those factoring techniques that we learned in the last class to factor the trinomial and then use the zero product property. Then skip problem 2 that's done for us and jump straight to these steps, solving a quadratic equation by factoring. It's exactly the same as what we saw before with solving a polynomial of the form p of x equals 0. You always want to make sure the equation is in standard form. That means you have 0 on one side and all of the terms on your other side. Then you want to factor the left-hand side of the equation using any of our factoring techniques. Then at that point, you can use the zero product property, set each factor equal to 0 and solve, and then check your answer. So for part A, it says we have 2x squared equals 13x plus 45. Right off the bat, you should recognize that this is not in standard form. Standard form means we have all of our terms on one side and 0 on the other side. Here we have our terms on both sides. To write this in standard form, I always like to keep my x squared term positive. So I'm going to subtract the 13x and subtract the 45 to the other side. That will then give us 2x squared minus 13x minus 45 equals 0. We can try the AC method or our guess and check method, okay, or trial and error. For trial and error, we would need factors of negative 45. There are lots of them, right? Well, not that many. 1 and 45, 5 and 9. Am I missing anything? Oh, 3 and 15. Few of them, you have to guess and check. You can also try to, like I said, use the AC method. Using the AC method, A times C would be what? Negative 90. So where did this go? A times C equals 2 times negative 45, which is negative 90. We want factors of negative 90 that add to 13. 18 plus 5, or sorry, negative 18 plus 5 equals negative 13. All right, so we're going to take the 2x squared minus 13x minus 45, and we're going to make that a minus 18x plus 5x minus 45 equals 0. So far, it's the same kind of steps that we had last time as far with the factoring. Now we just have that equals 0 on the other side. Okay, so then this gives us, if we factor by grouping, 2x times x minus 9 plus 5 times x minus 9 equals 0. So 2x plus 5 times x minus 9 equals 0. We have factored the left-hand side as much as, yeah, it's the left-hand. The left-hand side as much as possible. Then we want to use the zero product property. If we set each of these factors to 0, 2x plus 5 equals 0, and x minus 9 equals 0, then that gives us 2x equals negative 5, x equals negative 5 halves, and x equals 9. These are our two solutions. Our letter B, this is nicer because we have a difference of squares here. 16x squared is 4x all squared, and 49 is 7 squared. That equals 0. So the left-hand side factors to 4x minus 7 times 4x plus 7. And we have that equal to 0. Yeah, that's it. And then we set each factor equal to 0 and solve. So 4x minus 7 equals 0, 4x plus 7 equals 0. And that leaves us with 4x equals 7 and x equals 7/4. And 4x equals negative 7 and x equals negative 7/4. All right, so for number letter C, 3x squared minus 14x plus 8 equals 0. Again, here, we can't factor out the greatest common factor. This isn't a perfect square trinomial, so we can use the AC method. A times C in this case is 24. Factors of 24 that add to negative 14. Negative 12 and negative 2. Okay, so we're gonna break up the negative 14 to minus 14x to minus 14x minus 2x. This would be 3x squared minus 12x minus 2x plus 8 equals 0. We factor this by grouping. I always like to be careful with these minuses. So the first two terms are grouped together, then plus negative 2x plus 8 being grouped together. That equals 0. We factor out a 3x from the first term. That's 3x times x minus 4. And then from the second terms, we can factor out a negative 2. And that leaves us with an x minus 4, and it still equals 0. So finally, for factoring on the left-hand side, we get 3x minus 2 times x minus 4 equals 0. Then from here, zero product property. We set each of these factors equal to 0. Let's start with the one on the right. That's easiest. X minus 4 equals 0, so x equals 4 is one solution. That's the one we saw. The other solution would be 3x equals 2, so x equals 2/3. Higher degree equations. Usually when we have higher degree equations, we can factor out an x, or we can factor the greatest common factor somewhere, or we end up with difference of cubes or a difference of squares or something like that. And we can use, if it's a difference of cubes, we can use, or sum of cubes, I mean, we can use those two rules to factor, or we can factor out the greatest common factor. So for problem A, 8x cubed equals 24x squared minus 18x. For all of these problems, we're always going to want to write them in standard form, meaning all of the terms are moved to one side of the equation, zeros on the other side of the equation. Okay? So if you look at this, you don't want to start to try to factor the 24x squared minus 18x. Nope, we want to subtract the 24x squared to the other side and add the 18x. So we end up with 8x cubed minus 24x squared plus 18x equals 0. And then we want to start factoring. So on the left-hand side, 8x cubed and 24x squared plus 18x, all of those have a 2x in common that we can factor out. Is that all? Yeah, just a 2x. So if we factor out a 2x, that leaves us with 4x squared minus 12x, and then plus 9 equals 0. All right, now when you look at this trinomial, always look at the first term and the last term of the trinomial to see if they're squares. If they are, this may be a perfect square trinomial, which simplifies nicely. These are 4x squared is 2 squared, and then 9 is 3 squared. And then your question is that middle term 2 times 3 times, I'm sorry, 2x times 3 times x. It's negative that, so that'll work out. All right, so let's see. I'm gonna write this so you can see it very easily visually. This is, or 4x squared is 2x all squared. 9 is 3 squared. And then in the middle, we have minus 2 times 2x. Sorry, y'all, I did not make enough space. Start over. 2x times 2x squared. And like I said, down here, 9 is 3 squared. And then what do we want the middle terms to be? We have to check to make sure this is true. If it's true, then this works out. The middle term is minus 2 times 2x times 3. And it is 2 times 2x times 3. 2 times 2 times 3 is 12, times x is 12x. So this does work out. Okay, what does this tell us? That tells us that the middle part in parentheses factors to 2x minus 3 times 2x minus 3, or 2x minus 3 squared. Oh, wait, I'm losing it. Don't be like me. I got so excited about factoring, I forgot that that is not the end of our problem. Equals 0, equals 0, equals 0. Okay? You could have done the equal 0 from the last step where we have the 2x minus 3 times 2x minus 3. You'll get the same answer twice. That's okay. But from here, if we have 2x equals 0 and 2x minus 3 squared equals 0, this gives us x equals 0 as one solution. And then for the squaring, if 2x, we can just take what's in the parentheses and set that equal to 0. 2x minus 3 equals 0. 2x equals 3, and x equals 3 halves. For part B here, we have x to the 5th equals 625x. So we can move all of the terms to one side. 5x minus 625, I'm sorry, x to the 5th minus 625x equals 0. We can factor out an x from both of these. Hold on. Yes, factor out an x from both of these, and this is x times x to the 4th minus 625. And even though you might be looking at this like, oh, this is a 4th power, we haven't seen this before, x to the 4th is just x squared squared. So this is x squared squared minus 625 is 25 squared. So in the parentheses there, we have a difference of squares. X to the 4th minus 625 really factors to, we still have that x on the outside, x squared minus 25 times x squared plus 25. All right, you do not have to show this step. You don't have to show it. I'm just putting it here so you can visually see how we're getting this difference of squares. But you don't have to. You can go straight from step 2 to step 3. From here, though, can we factor anything else? We can. That x squared minus 25 is a difference of squares again. So we'll have x times x squared minus 25 factors to x minus 5 times x plus 5. And then for the x squared plus 25, that is prime. It does not factor anymore, so we'll leave it as an x squared plus 25. Equals 0, equals 0, equals 0. We still have to set each of these factors equal to 0 and solve for x. So let's do that. X equals 0, easy. X minus 5 equals 0, that's easy. X plus 5 equals 0. And x squared plus 25 equals 0. I want to start off with that last one. X squared plus 25 equals 0. This has no solutions. It's not possible to square something and add 25 to it and they get 0. But the rest of these give us solutions. X equals 0 is 1, x equals 5 is the other, x equals negative 5 is the other. All right. Boom. Now we can get to the other one, factor by grouping. All right, so for the last problem, we said that we had x squared plus 3x squared grouped together, and then plus negative 4x minus 12 grouped together equals 0. We can factor out an x squared from the first terms. That should be an x cubed. Factor out an x squared from the first terms, and we're left with x plus 3. And then we can factor out a negative 4 from the second terms. So minus 4, and that's times x plus 3 equals 0. All right, then from here, factoring by grouping, we can factor out the x plus 3, and we're left with x plus 3 times x squared minus 4 equals 0. And it almost feels like we're done, but wait, there's more. X squared minus 4 is a difference of squares. So this would be x plus 3 times x plus 2 times x minus 2 equals 0. All right, now that we've factored as much as we can, zero product property. Set each of these factors equal to 0 and solve for x. We get x equals -3, -2, and 2. All right, so let's go to activity 5.7. So if you look in modules, it says 151 OER activity 5.7. This activity just has more of the types of practice problems that we just did, kind of summarizes everything. So for problem 1, we're given a graph of a polynomial function p of x equals x cubed minus x squared minus 2x. And we're asked to find the solutions to the polynomial equation x squared minus 2x minus x cubed minus x squared minus 2x equals 0. This is just asking us to find the zeros. So if we look here, you see that the zeros occur graphically at x equals -1, x equals 0, and x equals 2. So using a graph, we just want to figure out where the graph crosses the x-axis. Not too bad. For solving this algebraically, we have to use factoring. On the left-hand side, we can start by factoring out an x, and we have x times x squared minus x minus 2 equals 0. Then that trinomial in the middle is going to factor to x minus 2 times x plus 1. So overall, once we factor, we get x times x minus 2 times x plus 1 equals 0. And we set each factor equal to 0 and solve for x. X equals 0 is done. Then we get x equals 2 and x equals -1. And of course, it does match up with what we found from the graph. Then the next group of problems, there are 4 of them. We're just asked to solve these polynomial equations algebraically, put them in standard form, factor as much as possible, and then use the zero product property. So for x squared minus 5x plus 6, this factors to x minus 2 times x minus 3 equals 0. Then if we set each of these factors equal to 0, we get x equals 2 and x equals 3. That one wasn't bad at all. I hope you thought so too. I didn't think it was too bad. All right, for problem B, this one's a little bit more involved because we don't have just an x squared, we'd have a 2x squared. But for 2x squared minus 10x minus 12, we can factor out a 2 from all of those terms. So factor out the greatest common factor. That leaves us with x squared minus 5x minus 6 equals 0. And then we can factor the remaining trinomial. That's going to factor to, we want factors of -6 that add to 5. Be careful with your signs here. It's not -3 and -2. It's actually -6 and +1. So this would be 2 times x minus 6 times x plus 1 equals 0. Another thing we need to be careful about. Technically, we're supposed to set each of these factors equal to 0 and solve for x. Our first factor that we got out there is 2. 2 equals 0. Does that give us any solutions? No, that's not true. So we can ignore that one. Then we have x minus 6 equals 0 and x plus 1 equals 0. So x is equal to 6 and x equals -1. And remember, I haven't been checking, but you can always take your answers, plug them back into the original equation to check. All right. Part C, when we look at these types of trinomials, we can't factor out the 4. Then we want to look to see, are the first term and the last term squares? 4x squared is a square, 25 is a square. Okay, that middle term is being subtracted. So you can come to the side and do this if you want. 4x squared is 2x all squared. 25 is 5 squared. And then negative 20x is 2 times 2x times 5. Negative 2. But that does work out. Okay, so this is going to factor to 2x minus 5. It's a minus 5 because that middle term is being subtracted, all squared. Or you can write it as, if it helps you visually, 2x minus 5 times 2x minus 5. Then we set our factors equal to 0, and we just get the same answer twice. So 2x is equal to 5 and x is equal to 5 halves. Then last one of these for part D. Notice that this one is not in standard form. A lot of times when we're doing a bunch of these problems, we're like, all right, no one needs a factor. You might look at that and say, okay, I can factor out an x on the left-hand side. We don't want to do that. We want to put everything in, or move all of the terms to one side first and then factor. So this would be 2x squared minus 9x minus 5 equals 0. And then for this trinomial, we can factor it by grouping or factor by trial and error. Trial and error might not be too bad because 5 doesn't have many factors and 2 doesn't have many factors. So this is 2x and an x. And then the last two terms have to be negative 5 and positive 1 or positive 5 and negative 1. Those are the only options. Those are the factors of negative 5. The ones that work, because we need a negative 9 in the middle. So we'll put plus 1, 2x plus 1 and x minus 5. You can check with FOILing that this works. The 2x times a negative 5 gives us a negative 10x, and then the x plus times 1 gives us a plus 1. So that's minus 9x in the middle. All right, so this is the factorization that equals 0. We set each of these factors to 0. We get x equals negative 1/2 and x equals 5. Use the graph and or table of the polynomial function to solve the polynomial equation, then solve the polynomial equation algebraically. So for the first one, okay, I guess it's matched up with the graph above the function. For part A, we want to know when x squared minus 6x minus x minus 6 is equal to 0. We can see here that the x-intercepts are at negative 2 and 3. So x equals negative 2 and x equals 3 should be our solutions. If we solve this algebraically, when we factor this, we get x plus 2 times x minus 3 equals 0. So x plus 2 equals 0, x minus 3 equals 0, x equals negative 2, and x equals positive 3. So we can see that these algebraic solutions do match up with the x-intercepts in the graph. Right. For part B, we have x-intercepts at negative 2, 0, and 2. So those are the answers we should expect to get when we solve algebraically. This is cubic. Notice how this one has an x cubed and we end up with 3 answers, 3 answers for x. That usually happens with polynomials. So for x squared minus 4x, we can factor out an x, and then this is x times x squared minus 4 equals 0. X squared minus 4 is a difference of squares. So we have x times x minus 2 times x plus 2 equals 0. And if we set each of these factors equal to 0, we get x is 0, x is 2, and x is negative 2, which matches up with what we saw in the graph. All right, from the table, remember with the table, we're looking for our output to be equal to 0. That happens on the second row and the fourth row. So from here, this is showing us that these x values, -1 and 1, are our solutions. Solving x squared minus 1 equals 0 algebraically, x squared minus 1 is a difference of squares, so it factors to x minus 1 times x plus 1. And then if we set these two factors equal to 0, we get our answers that we have in the table, 1 and -1. Number 4, x squared plus x equals 6x cubed. I like to, so pay attention here. X cubed is the highest power of x. I personally like to keep my highest power of x positive. I think that is helpful. So I would move all of the terms to the left hand or to the right hand side in this case. If you prefer to have everything on the left hand side all the time, that's fine too. It'll work out almost exactly the same. But here I am going to make the left hand side 0, and then we'll have 6x cubed minus x squared minus x. And then I am going to factor out an x. So we have x times 6x squared minus x minus 1. And then factors of -6 that add to -1 would be -3 and +2. So this factors to, let's see, 6x times something times x. I lied. That's wrong. Sorry, I was factoring by grouping. So we said this would be 6x squared minus 3x plus 2x minus 1. And then if we factor this by grouping, we're going to need more space. This is x times 6x squared minus 3x plus 2x minus 1, which then factors to x times, we factor out a 3x times 2x minus 1 plus 1 times 2x minus 1, which factoring's almost over. We have x times 3x plus 1 times 2x minus 1. All right. Now we set all of these equal to 0. So x equals 0, 3x minus 1 equals 0, and 2x, that's right, 2x minus 1 equals 0. All right, x equals 0 is one answer, 3x equals 1, so x equals 1/3 is the other, and 2x equals 1, so x equals 1/2 is the last one. For part B, 2x cubed minus 12x squared plus 10x equals 0. We can factor out a greatest common factor here, which would be 2x. So we have 2x times x squared minus 6x plus 5 is 0. Then x squared minus 6x plus 5 factors to x minus 5 times x minus 1 equals 0. Setting each of these factors equal to 0, we get x is 0, x is 5, and x is 1 as our solutions. All right, and last one here. Given that the cost of producing x units of a product is given by the polynomial function c of x equals x squared minus 4x plus 5, find the number of units manufactured at a cost of $145. So this is an example where we're given the cost. So this is telling us that this c of x equals 145. So if we set that up, we end up with a polynomial equation that we can solve. All right, so x squared minus 4x plus 5 is equal to 145. And we are asked to find the number of units. So find x that makes this true. All right. If we subtract 145 from both sides to put this in standard form, we get x squared minus 4x minus 140 equals 0. All right, so factoring this, and if you need to come to the side, you can do it. We need factors of negative 140 that add to negative 4. All right, factors of negative 140. Oh, I got it. 10 and negative 14 would work. So 10 and negative 14. Add to negative 4, multiply to negative 140. All right, so this is x plus 10 and x minus 14 equals 0. So setting the factors equal to 0 gives us x equals negative 10 and x equals 14 as our answers. However, in this application problem, x is the number of units that we are producing. Does it make sense for x to be negative? It does not. So in an application problem like this, where a negative answer doesn't make sense, we can exclude the negative solution, and x equals 14 would be our solution.